Okay, so it seems that the recording from yesterday, halfway through, it started glitching. So we're going to go over rotations again. Luckily, translations was okay in the video, right? All right. So, rotations. Do y'all need a minute to get here? Okay. All right. We have seen that reflections and translations are two types of rigid motion. Who's going to refresh my memory and tell me what does it mean to be a rigid motion? Good. It's basically saying its image and its pre-image are congruent. So we could slide it, we can flip it, we can rotate it, but it's still your image and pre-image are the same shape, same size. Ultimately, they're congruent. The final rigid motion we will consider is a rotation. A rotation turns all points of a plane around a point called the center of rotation. The angle of rotation tells you the number of degrees through which points rotate around the center of rotation. So, something pretty important, when we talk about a rotation, it's always counterclockwise. So we're always rotating counterclockwise unless we specifically say rotate it clockwise. So if I just say a 90-degree rotation, you're going opposite the way the clock works. We are not going to investigate. We are not going to create our own rotations. We're not doing this. So we're moving on right to here. So there's a couple of shortcut rules for certain rotations. So we're saying if the center of rotation is the origin, there are some shortcut rules. The angle of rotation, if the angle of rotation is 90 degrees, the rule tells us take XY, negate the Y, then switch their positions. That's if it is a 90-degree counterclockwise rotation. If it's a 180-degree counterclockwise rotation, it is saying take X, Y, and just negate them both. Keep them exactly where they are, just make them the opposite sign. And if it's a 270-degree rotation, what they're telling us to do is take X, Y, negate the X, then flip X and Y. And let's just look at this. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. If my pre-image is in quadrant 1, and we're doing a 90-degree counterclockwise rotation, so you're rotating basically a right angle, wouldn't it make sense that we'd end up in quadrant 2? Right? And again, if we're in quadrant 1, now we're doing a 180-degree rotation. So 90 degrees would get us in quadrant 2. Then another 90 degrees, wouldn't that get you into quadrant 3? So that's that. And then if we're doing 270-degree rotation, if our pre-image is in quadrant 1, 90 degrees is in quadrant 2, then another 90 degrees in quadrant 3, and then another 90 degrees would bring us to quadrant 4. So it makes sense. Okay, so let's perform a rotation. It says draw the image of the quadrilateral under a 270-degree rotation. So what I'm going to do first is I'm going to list out all my pre-image points. So we are at 0, 2 is 1 pre-image point, and then we're at 1, 4. Then we are at 3, 1. And lastly, we are at 4, 2. All right, So now the rule for a 270-degree rotation tells us negate the x, then switch x and y. So what does that mean? Can I negate a 0? No, but can I still switch the x and y? Absolutely. So now this becomes 2, 0. So we'll plot that. All right, then we have the 0.14. It says negate the x. Well, when I negate the x, it's going to become -1. But then after I negate the x, what should I do with x and y? Switch them, exactly. So it becomes 4, -1. We're right over here. And again, negate the x, then switch them. So I'm going to negate the 3, and then I'm going to switch them. So we're at 1, -3. And then the last one, negate the 4, and then switch it. So it's 2, -4.
Are you going to memorize this?
No.
Okay. Oh, wait. You have
The delta math. And there we go. And doesn't it make sense that we would end up in the fourth quadrant, right? 90, 180, 270. Okay, I want you to try try number 4 on your own.
Now you have to measure 5 places. You can't read it.
All right, so what I would do if I were you, I would write out all my pre-image vertices. So we are at -3, 1, -4, -3, -1, -4. And now I would follow the rule. Who looked back and saw the rule? What did the rule tell us to do? X, Y is going to give us, Mia? You got it, -yx. So we're going to first negate the y. So +1 negates to -1, and then we flip it. So -1, -3. We'll plot that. And then for -4, -3, when I negate a -3, it's not -3. What's the negation of a -3? What's the negation, Julia? 3. So now we're going to be +3, -4. And then lastly, -1, -4, we're going to negate a -4, which becomes +4, and then -1. And there is our 90-degree rotation. Okay, so now what we're doing is saying use coordinate notation to write a rule for the rotation that maps triangle ABC to A prime, B prime, C prime. So what I'm going to do is I need to figure out what's happening between ABC and A prime, C prime, C prime. So to help me, I'm going to list the coordinates. So my point A is the point 1, 2, 3. And then 1, 2, then -2. Our B is going to be 2, 3, 4, +1. And then C is 1, 2, up 2, so 2, 2. So now let's see what happened from A to A prime. So from A to A prime, now A prime is 1, 2, 3. And then up 1, 2, 3. So we went 1, 2, over 3, up 3. Something go wrong here? Okay, and then for our B prime, yes. Oh, did I miss something? Oh, x is 2. Thank you. A prime x is 2. Thank you. All right, now B prime, we are -1, but then up 1, 2, 3, 4. And then our C prime, we are -2, +2. All right, so now we have to sort of figure out what was going on here. So from A to A prime, we had 3, -2, but then we had 2, 3. So what does it look like? That -2 went to a +2. So didn't it look like we negated the y and then switched it? All right, let's see if that follows the rule for the other ones. 4, 1. So we're saying negate the y, then switch it. So if we did that, 4, 1 would become -1, 4. Did that work out? Yeah, let's look at C. 2, 2 becomes -2, 2. Did we negate the y and switch it? Yeah, so we negated the y and switched it. So now it told us to write the rule in coordinate notation. So the rule is going to be xy yields -yx. We negated the y and we switched it. So then it's asking, well, what angle of rotation does that? What angle of rotation negates the y and then switches it? A 90-degree rotation. You got it. Oh, 90 degrees?
Oh, I think it's
Yes, 90. No.
Yeah. Yes, it's 90
Yes,
degrees.
90. Okay, so then we're going to do a 90 degrees rotation. Yep, you're right. It is a 90-degree rotation. Yeah. All right. Sure. We good? All right. So now it's asking us to do multiple things. So now it says reflect triangle JKL across the x-axis, then reflect that image across the y-axis. Draw the final image of the triangle and label it J prime, K prime, L prime. All right, so let's do this. First, we're going to take triangle JKL and reflect it across the x-axis. So for this, I just like to count and just create a mirror image on the other side. So here's our x-axis. If I'm reflecting over it, that means point L is 1 unit above the x-axis. So now I'm going to go 1 unit below the x-axis. K, again, is 1 unit above the x-axis. So the same level, I'm going 1 unit below the x-axis. And then J is 1, 2, 3, 4 above. So now I'm going 1, 2, 3, 4 below. Everybody okay with how I got that new reflected triangle? Okay, but I'm not done. What are they saying to do now? Reflect this purple image across the y-axis. So I'm going to take the L and I'm reflecting it over the y, and they say call this L prime. Then take the K and reflect it over the y-axis. That's my K prime. Then take your J and reflect it over the y-axis. And call it J prime. Okay, so now they're saying describe a single rotation that maps JKL to J prime K prime L prime. Okay, well, let's look what happened. We had, I'm just going to look at one of the coordinates. We had point J, which was the point 1, 4. And then it went to J prime, our final one, which was -1, -4. Do we agree? What rotation negates both the x and the y but keeps their positions the same?
180.
180. And doesn't this make sense counterclockwise? 90 degrees and then 180 degrees, right? 90 and then another 90. So then one single rotation would be 180-degree rotation. And then they say use coordinate notation to show that your answer to number 7 is correct. So all we're doing is xy yields -x, -y. All right, are we ready for the very last problem? All right, a student was asked to use coordinate notation to describe the result of a 180-degree rotation followed by a translation 3 units to the right and 5 units up. The student wrote this notation. Now, guys, we're going to sort of use our algebra knowledge to make sense of this. Describe and correct the student's error. If they're saying describe and correct the student's error, is the student correct? No, they're saying identify the mistake. So clearly the student's not correct. So let's try to understand what they did wrong. So they want us to first do a 180-degree rotation and then translate it. Well, according to algebra, PEMDAS, order of operations, don't we do the innermost parentheses or brackets first?
Yes.
So if we're looking inside first, what are they telling us to do here? What within? Isn't it saying x plus 3 and then a y plus 5? So is that a rotation that they're telling us to do first? That's a rotation? No, what is x plus 3, y plus 5? It is coordinates, but out of all the rigid motions that we learned. It's a translation, right? They're saying move this figure 3 units to the right and 5 units up. Isn't that a translation? X plus 3, y plus 5. But did they tell us to do a translation first? No, what did they tell us to do first? What did they ask us to do first in the directions? They did not say do a translation first. They said perform a 180-degree rotation first. So now we got to figure out how we would do that. So if we're going to do a 180-degree rotation, what's the rule for a 180-degree rotation?
Negate the x and the y.
Good. So first we're negating the x and we're negating the y. Are we okay with that? That's what we'd have to do if we're doing a 180-degree rotation first. First negate the x, negate the y. And then what are we going to do? Now we're going to do the rotation. So then they say after you negate the x, translate it 3 units to the right. And after you negate the y, we're translating it 5 units up. So this is what the notation should look like, because now it's saying rotate it, do your negations first, then translate it. So what are we going to do? Describe the student's error. The student translated, then rotated. So the student performed the transformation in the wrong order. All right, so then we are done.